Well, hello and welcome to this exercise on sequence. I think it's the fourth or fifth in my series on sequence. This is, again, an iGCSE GCSE high school algebra type question. There are four parts and they're all graded. Okay, so here it says, here is a sequence, and the sequence is 4, 7, 10, 13, and 16, and so on and so forth. It then says, write down an expansion for this sequence. It says write down, but I'm not going to just write it down. I should try and show how I got my answer. So here's my sequence again. 4, 7, 10, 13, and 16. As you can see, moving from left to right, the numbers are increasing by 3. And if you move from right to left, the numbers are decreasing by 3. Okay. Right. Now, if I now pretend that I've got a number there just before the 4, and because it's to the left of 4, it's not going to decrease by 3, so 4 minus 3 gives us 1. So that's what we got there. So again, that's decreasing by 3 there. So the expansion or the formula we want would be 3n plus 1, or 3x plus 1, or 3z plus 1. You can use whichever variable you wish. Okay. Now, don't forget my 1, this 1 here, comes from there. And my 3 in 3n comes from there. So the 3 comes from there. Okay, so for that, you get 2 marks. And for part B, and that says expand 3x plus 1 by and multiply by 3y plus 1. Again, this is a grade C type question. And what I've done here, or what I usually do, is to draw the table because it diminishes the chances of making a mistake there. It's not the shortest way, but it makes sense to do that way for me anyway. So I end up with 3y times 3 is give me 9xy, and then 3y plus 1 will give me 3y, and 1 times 3 is give me 3x, and 1 times 1 will give me 1 there. So when I tidy up, I end up with 9xy plus 3y plus 3x plus 1. And for that, I get 2 marks. Now, for the third one, which I think is a bit more difficult, grade B, and it says hence or otherwise. Hence, that implies we can use the same principle that you use in part B. Okay, so it says hence or otherwise, show algebraically that the product of any two terms of the sequence above is also a term of the sequence. So in other words, we want to have something similar to 3n plus 1, or 3x plus 1, or 3z plus 1, or 3n plus 1, whatever. Okay, now what you must not do, you must not say that 7 times 10 is 70, and 70 is the 13th term of the sequence. That's not good enough. You will not get any marks for that. It says algebraically. So now, if you look at a sequence that occupies the nth position, and a sequence that occupies the n plus eighth position, if that makes sense. Okay, so we end up with 3n plus 1, which is the general sequence or general expansion from part A, multiplied by 3 into n plus a, because 3 to n plus a plus 1 will be the n plus the will be the number that occupies the n plus 8th position. If we now replace n plus a with y, we shall expand to give us 9ny plus 3y plus 3n plus 1, which we get, if you like, similar to what we got in part B there. Except for part B, we now have n instead of x. Now, what I'm going to do now is to try and factorize the first 3 terms of this expression here. 9ny plus 3, y plus 3n plus 1. I'm going to factorize the first 3 terms. So we end up with 3 into 3ny plus y plus n, close brackets, plus 1. If you then say, let z be 3ny plus y plus n, so we end up with replacing this bit here with z. So we end up with 3z plus 1, and that's similar to 3n plus 1. So now, we've now shown that if we multiply any two terms, we're going to get a term in the sequence. So 3z plus 1 is very similar to 3n plus 1. So for that, we get 3 marks. And I think this is a difficult question that this one is. Anyway, never mind. Now for part D, if you can do part C, you can do part D. Part D is so much easier. Right. We got a sequence 2, 4, 8, 16, 32. And we can express the sequence in the form of 2 to the power n. It then says, show that the product of any two terms of the sequence is also a term of the sequence itself. Very similar to part D or part C. But if you can do part C, you can do part D. So again, looking at two terms, the term that occupies the nth position and the term that occupies the n plus 8th position there. If we then multiply two of them, 2 to the power n multiplied by 2 to the power n plus a, and because we multiply by indices, we're multiplying using indices, the answer becomes 2 to the power n plus a, which is 2 to the power 2n plus a. Now n is an integer, and n plus a must be a positive integer as well. So now if we then replace n plus a with p, so instead of having 2 to the power 2n plus a, we then have 2 to the power p. So the pth term of this sequence is 2 to the power p. And that's similar to what we got, or what's given to us in the question itself. Now, I hope all that made some sense, and please subscribe. Thank you for watching, and bye-bye now.